Hey, welcome to section 6.2. In this first video, we're going to be talking about one-to-one functions, which are essentially a precursor to invertible functions. All right, so generally a one-to-one function is a function that for every unique output has unique input. So let's just write down what that means. It is a function for which every output has a unique input. Essentially, this is the flip of what it means to be a function. So when we had something that was a function, it was that for every input, there's unique output. Now for every output, we also have a unique input, meaning that if we know f and evaluate and know, and we know that f of x equals some number c, then we know x. So essentially, if we know what function we're working with and we know the output, then we know what was put in. A real world example. In class, we talked about phone numbers, how if someone tells you that they called a phone number, and if you work for AT&T or something, then you can determine exactly who they called because you just match the person to the phone number. Another real world example is almost the same thing where we have TV channels. So you change the channel to ESPN, then I know you entered, I believe it's, well, actually I have no idea. It's something like 729, at least for DirecTV in the SoCal area. So if we're looking at functional or mathematical functional examples, a one-to-one function would be, say, f of x equals x cubed. So in this case, we know f of x. Now, if someone was playing with the function and found that for a number x they plugged in, let's actually differ from x, call it a number c they plugged in, they got out 27. Now, because f of x is one-to-one, you can say exactly what c is. We can just solve x cubed equals c, or sorry, x cubed equals 27. And then implies that x equals 3, c equals 3. And there we have it. But a non-example would be the function f of x equals x squared plus 1. Because if someone was playing around with the function and found that f of c, in this case a different c than above, was 17, then is c equal to 4 or negative 4? And we don't know. So therefore, we cannot determine what C is. Therefore, this is not a one-to-one function. So for the output of set 17, it has 2 inputs instead of a unique input. Graphically, it's actually really easy to determine what functions are one-to-one. So just like this is like the vertical test, the vertical line test. Let's say we have a graph. So we have an axis. We have a blue function. And on this graph too, let's put on this red function. And now our horizontal line test states that a function passes the horizontal line test if every horizontal line intersects the graph at most 1 point. And if it passes, that implies that it's one-to-one. All right, so with this in mind, take a look at this blue function, this red function, try to determine if they're one-to-one functions. Okay, so looking at the blue function, it is one-to-one. For every horizontal line we draw, it intersects at exactly 1 point. This red function, as we can see from this line we just drew, is not one-to-one. We have 2 functions. So what it says is that we have these 2 points that map to the same output, where this line maybe at A. So these 2 values, x2 and x1, map to the same point. Therefore, it is not one-to-one. But this blue function is one-to-one. And so that's all we have to do to check. We just look at the graph, see if it looks like every horizontal line passes through at most 1 point, and we're done. And a little note on why we say at most 1 point. If we had the graph of 1 over x squared plus 1, it could look something like this. I guess this one's still not one-to-one, but what's happening is that we could have some values up here that never get hit, and that's actually fine for a one-to-one function. So I guess we could make it instead something that looks like this, where it starts to flatten out. Then it's one-to-one, so long as it's still increasing. All right, so that's it for one-to-one functions, but we'll be seeing their role in inverse functions in the subsequent videos. All right, practice some practice problems, especially just trying to find functions that pass the horizontal line test and don't pass the horizontal line test. All right, see you in the next video.